All right, welcome everybody. You've surely seen the welcome slide by now, probably sick of it, so we'll get rid of it. There we go. What we're going to be talking about today is extending DevOps to SQL Server databases, and pretty excited about this topic. I love this topic, frankly. I think it's really important, not just interesting and fun, and cool work, frankly, but really important to how we deliver software. So my name is Grant Fritchey. I work for Redgate Software, and this is my contact information. If you want to get in touch with me, that's my blog, that's my email address, Twitter handle. You can definitely get in touch, and I will try to answer any questions you have. I don't get a whole lot into the whole, I've got so and so many years of experience in the industry, but I've been working here for quite a while, and I've done quite a lot, and I try to help out where I can. Let's just put it that way and move forward. With me, Arneh, you want to take this one?
Sure. Hey, everyone. My name is Arneh Eskandari, and I'm also with Redgate. Been with Redgate for just over 6 years as a sales engineer. And as part of my role, I've worked with a lot of existing customers as well as new customers, helping them implement DevOps best practices for databases, both as part of pre-sales, POC setup, and implementation, as well as post-sales training and rollout as well. So here are my contact details, so if you have any questions, feel free to reach out.
Excellent. Thanks, Arneh. So this is what we're going to run through today. We're going to talk a little bit about Redgate, and then we're going to talk about DevOps, the importance of it, why DevOps is so important, why there's a thing, the benefits of DevOps, and frankly, what we can do from Redgate to help you guys out with DevOps. It's a huge topic, really, but we're going to spend a little bit of time on it today and kind of run through it. So let's talk to you about Redgate. We are a tools vendor, frankly. We build a lot of different kinds of software, and that software is focused and designed around helping you build, deploy, manage databases primarily within the Microsoft data platform stack, but we also support some other stuff. We've got a whole bunch of developers that are working to build our tools. We're in 91% of the Fortune 100 companies and a pretty substantial portion of companies around that. Our focus is really very much on trying to help. We are a for-profit business, but our business is assistance. Two of the things that we do to try to help you guys out is we run Simple Talk, which is a fantastic journal, 400,000 subscribers, lots and lots of fantastic, tuned, peer-reviewed, technically reviewed articles that are deep and wide on various topics in and around the data platform. We also have the largest SQL Server community online, SQLServerCentral.com, with 1.4 million registered users and counting. And that's a great set of forums to go and get help. If you have questions after today, please get in touch. We want to try to help out. I see you're already running the poll. Cool. How are we doing? 71% use compare and data compare, and I don't blame you guys. I had that open on my desktop all day long when all I did was be a DBA. It was absolutely the most important tool I had in my toolbox. More than half of you, almost half of you use source control, and a bunch using monitor and prompt. That's cool.
Exactly, that's impressive. Almost 50% using SQL source control. That's really good.
Yeah. Oh yeah, it's good news. Cool. Awesome. So that's enough about Redgate. Although we could talk about Redgate for a long time if you want us to, but we'll go ahead and move on. So let's talk about DevOps. Let me just say that the most important thing to think about DevOps is to not get too hung up on the name. A lot of people see DevOps as, this dev thing. Development is taking over operations, right? Dev is before ops, and so therefore it's, Well, no, it's not. That's not what it's about. The goal of it, and if you look up online, if you look up the various, definitions, and there's a bunch of different ones. I mean, there's different organizations and different groups have put together the definition, but the definitions largely coalesce around the idea that this is not a mechanism for developers to run the world. It's a mechanism for all of us, dev and operations, to communicate better, to work together better in order to deliver software faster into our production environments while still protecting our production environments. So the deal is that we have, databases have a unique problem, and that's around data persistence. The fact is that, code is replaced on a regular basis, whereas data just isn't. Data is maintained, data is kept, data lives for a very long time. And the more business critical that data is, the more it's driving your business, the more critical it is that data does not go away. And so we have to ensure that any of the data that any of the information, shouldn't you say data really, any of the information that we've gathered is safe, it's protected, and frankly, the changes that are necessary for us to have a thriving, growing, moving business, we have to protect that information from that growing, moving process. And so databases have to be managed as part of a rollout of new or updating existing software, but it's vital that we do both things, that we protect the information that we've already gathered in whatever source we've gathered it in, whether it's SQL database, Azure SQL database, Azure SQL Data Warehouse, Cosmos. I mean, you pick the database, it doesn't matter what it is, but the goal here is to protect that data and move software out the door as fast as possible. So the issue we run into is that databases frequently are not keeping pace with development. Development's moving at a mighty clip. It's just going forward fast. There's constantly stuff going on. There's movement, change, new functionality, different functionality, additional services, all of these kinds of things just moving so quickly. Whereas data, again, that persistence tends to slow things down, tends to retard growth and change. Also, it becomes very difficult from within a database, within a single database, to monitor what is being changed. It's, if you're using various kinds of processes around DevOps and source control, and almost half of you have SQL source control, sure, you can tell what's going on, but less than half of you use SQL source control, so over half of you may not have a source control system in place. And Arneh, I'm getting complaints that people say that they can't hear.
So I think what they mean is that their mic is muted.
Oh, well, yeah. Okay, cool. I'll just keep going. I just wanted to make sure people could still hear me. Changes within a database occur literally invisibly. You can't see who made a change to a database. Yeah, there's some auditing tools you can add, but unless you've added those auditing tools, there's no way to tell. There's monitoring methods that you can add, but unless you've added those monitoring methods, there's no way to tell. And so when it comes time for audit, when it comes time for someone to come in and say like, hey, for a compliance, for legal compliance, for ethical compliance, for protecting client information, protecting healthcare information, how are you managing and monitoring your database changes? You're going to need something in there to be able to tell people, otherwise you can't. So you're going to have to add these processes, add these methods to make sure you can do that. It's also, quite frankly, very difficult to roll back changes inside of a database. Frankly, most of the time, you can never roll back changes inside of a database. And the reason I say that is because usually what happens, and it's not always, but usually what happens is you'll release some piece of new code, you'll release some new piece of methodology within your database, and people will start adding data. Then you'll find a problem, but that's too late. There's already data changes in there. You can't simply undo the changes you had previously and simultaneously protect the additional data that's been collected. So you've got to have methods, frankly, for rolling forward to a new version of a database. Databases, by their very nature, because of the size of data, because of the big, huge, giant databases that are under management, they can affect the ability to do agile delivery. Yeah, okay, so this one guy's just saying he has no sound. Okay, so you're the only one. So yeah, can you just point it out to him, Arneh? I'll keep going. So what happens is that people will start to slow, in order to, to protect their production system, what happens is people will slow down. They'll slow down their deployments. They'll slow down the number of deployments that go out into production around their databases. And what that means is that you're going to get bigger and bigger and bigger deployments. More and more changes accumulate because development itself doesn't slow down. Just your release of it into your production environment does. And so the more, the less frequently your releases are, the larger your releases get. We're not changing a table, we're changing 10 tables. We're not changing 10 tables, we're changing 100, 1,000. We're not changing one sort procedure, we're changing 50. As you accumulate these changes, they actually become not safer, not more protected, it becomes less protected. And so we see Agile being literally kneecapped by databases and database management systems, and frankly by database managers, by the people in charge of making sure these databases are protected. They're actually making them less safe. They're making them, more prone to problems because you're making fewer larger releases. And also, a lot of times there's manual processes involved. Lots and lots and lots of DBAs think they need to read all 10,000 lines of a script before it can get released out to a process. So they don't use continuous integration and continuous delivery to the full extent that they can be through automation, through methodologies that allow you to not simply deploy a database, but deploy a database in an automated fashion that allows for testing and validation in order to move more changes quickly as opposed to more changes slowly. And frankly, we spend a lot of time doing database deployments. It takes a very, very long time. And so all of this stuff, all of these cumulative effects of poor choices in the methods with which we deploy databases make databases very problematic for an agile process, make databases very problematic for DevOps, because DevOps is focused on moving quickly, automating everything, treating your infrastructure as code and treating code as infrastructure. That's a huge part of the DevOps process, is making sure you've got these things in place. And frankly, in the data sphere, we just haven't quite yet bought into that whole thing. And so it's getting on board with that's going to start make a change here. Now, the benefits that you get if you move into a DevOps process, if you move into automating your database lifecycle management and stepping, much more closely in line with how your developers develop and frankly with how your developers release code, you get a whole bunch of benefits out of this. The biggest thing is that you get reliability in your process, mainly because you're going to be exercising your process a lot. Rather than running a deployment once every 6 months or once every 3 months or even once a month, you're going to run deployments once a week, daily, several times a day maybe. Certainly within your continuous integration environment, you're going to be running deployments 4, 5, 10 times a day. that means that you know how your deployments behave. So you're going to have a very, very predictable process. You're going to have a process that you can automate. And by automating, you remove a lot of the impediments that slow things down. By speeding things up through automation, you're going to move code out the door faster. And by speeding things up through automation, you're going to have the ability to do more testing. Because you can do more testing, again, this feeds back into the reliability of the process. Because you can do more testing, it's going to speed the process, and you can do more releases. And so it just becomes this absolutely wonderful cycle of a positive feedback loop. The more automation we do, the more testing we can do. The more testing we do, the more accurate our deployments are. So the more accurate our deployments are, the faster our process is, the more changes we can get out the door. So it just becomes, a gratuitous, happy set of changes. It moves you forward. You're not fighting with your development team because you're approaching from a DevOps point of view. You're embracing what they do and how they do it, automating your end to ensure that you're working the way they work. I can't begin to tell you the benefits that it's gotten across within the teams I've worked with, but also within the companies that we sell this stuff to. It really has made a positive change in what they do and how they do it. So we did, there was a survey called the State of DevOps, and it was a full-on report. It's available. You guys can download it yourselves. And what they found is that there is, frankly, a very tight correlation between the practices of things like version control and continuous delivery and the performance of your IT team. The more your IT team works off of automation, the more time you spend not doing manual processes, not walking through all of your code, the more time you spend automating your things, treating your infrastructure as code, the better your IT organization is as a whole. Not simply your development, not simply your ops, but your DevOps. Your entire org improves as you move into automation through version control, through continuous delivery. They've also found that high-performing IT organizations are more agile. They move faster. And the fact is that the high-performing organizations that move faster are also more reliable. So they're deploying code 200 times more frequently, but with 3 times the lower change failure rate. That's amazing. That's just incredible. You're going to deploy a lot more stuff out the door, but you're going to have fewer failures. What could go wrong, right? How can you complain? They also found that the organizations that have a good IT organization, the overall business that has a good IT organization is twice as likely to exceed their profitability, market share, and productivity goals. So it's all down to the fact that it's the modern age. As my children are constantly reminding me, it's modern year. It's current year, Dad. So anyway, the whole idea here is that we are in the technology age. It is the time of IT. It is the time of information. And so we need to jump on board with that and start to treat information management, information gathering, information maintenance the same way that we treat code in order to achieve this 200 times more frequent, 3 times lower change failure rate. All of these positive outcomes come through automation, come through the methodologies that we're using to, get this stuff to treat your infrastructure as code and not simply treat your, infrastructure the way we've always treated it, which, someone looking at a GUI and clicking next, 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 okay. It's just not the way to get things done in this modern age. We have to move faster, but we have to move safer. And so that means coming up with process that protects us and protects our information. And so that's what we're talking about today. Now, we think we've got some solutions for you guys. We think we can help out. I mean, like I said, Redgate's big thing is we try to help. So let's talk about how we can do it. So if you're looking at DevOps, and if, you know, I've always disliked this particular drawing, not because it's not accurate. It is very accurate. It's a great way to lay the stuff out. It's very visible, but I really prefer the circle because I like to think of this as this constant ongoing thing. But let's just talk about it for a moment. Development, you know, right, developers are going to be sitting there. They're going to be in the background. They're working on Visual Studio. They're working on Management Studio. They're checking stuff in and out of source control. Well, while they're doing all that, Redgate's pitching in to help out. We've got SQL Prompt that works within Visual Studio or Management Studio to help you with your, you know, writing T-SQL, formatting it, frankly, figuring out the correct syntax because we've got syntax checking built right in. We've got SQL Source Control that's checking the code in and out for you, and we've got SQL Test that's allowing you to do testing automation. And so all of that works within a development process. You check code in and out of source control, triggering a build, which goes through a continuous integration process. All of the source control, well, it works with Mercurial, Perforce, Vault, Subversion, yes, Git, GitLabs, GitHub, Visual Studio, and TFS, Team Foundation Server, which also works with Git and GitLabs and GitHub. So all of this stuff goes through in and out of source control, and then it goes through the continuous integration process. And frankly, we've built out our tools for automation, and so they support PowerShell, and therefore it works really tightly with TeamCity, Jenkins, Bamboo. You can plug in Cruise Control, Go, and again, you can use the Visual Studio Team Foundation build process, which I've been using that a lot lately, and I've kind of fallen in love with it. It's a pretty cool set of tools. Finally, once you kind of got your builds in line, you go through a release management process so that you can go through your various environments. You go from testing to QA to some sort of pre-prod or staging environment. You're going to generate an artifact at some point along this process, and that artifact is going to get tested over and over again. It's going to get tested in QA. It's going to get tested in your pre-prod, and all of that artifact gets managed through these release management softwares such as Bamboo, Octopus, or again, Visual Studio. Finally, it's going to go into your production environment. And in your production environment, you're going to monitor this process and you're going to back up your code. And so once more, we've got tools in line that are going to help you with it. SQL Monitor, DLM Dashboard, SQL Backup. The big thing about SQL Monitor is that you're going to be able to know when releases go out the door. And once you know when release goes out the door, you've got a before and after point to observe the behavior of that release. And you can identify, hey, yes, this has helped us out and it's great, off we go. Or gosh, I don't know, we're seeing some regression here. Maybe we need to make another change and we'll go back through the cycle again. We'll go back to the beginning, make some changes, check it into source control, validate it through CI, put it back through the release management system, and then off it goes back into production again. And then we're just going to do this over and over and over again. So that's pretty much where we're at. Now, our focus today is going to be largely around the development process. We're going to focus down in what's going on within development, and Arneh is going to do a little demo for you and walk you through some tools that even I actually haven't seen before. So I'm kind of excited to see what he's going to be doing today. Whoops, missed a couple of slides here. So yeah, so the whole idea here is that it does create this artifact, and the artifact is what? It's T-SQL. I'm sure most of you who are managing any kind of databases today know what T-SQL is, and so that's what we're talking about. Oh, this is just walking me back through all the stuff I just did. So let's keep going.
Yeah, I think we can jump right into the demo.
Right, yeah, there we go. Sorry about that. I walked through all that stuff, and then we had a slide that walked us through it, so. All right, so you want to take over?
Yeah, sounds good. Thank you so much, Grant.
Thank you.
So let me go ahead and quickly make myself the presenter here. All right. So hopefully everyone can see my screen okay. Grant, could you confirm that you can see my
Yes.
screen?
Yeah, I can see it
Okay,
just fine.
perfect. Okay, excellent. So for today's session, we're basically going to show you how you can manage your database changes end-to-end from development all the way to production. And we're going to be using the Atlassian stack, which includes JIRA, Bitbucket, and Bamboo for keeping track of our stories, as well as the changes that we make in and commit them to source control in Bitbucket, and using Bamboo to basically validate our changes, run automated builds, and also do releases to our hiring environment. So as Grant mentioned earlier on, collaboration and communication is really the most important piece of DevOps. So utilizing tools like this will actually make that process a lot easier and smoother as far as collaboration, communication, making things a lot more visible so your operations people will know exactly what's going on the dev side of things. So when it comes to doing deployments, they'll know exactly why certain changes are going out and why. So that will basically help reduce the conflict and resistance between dev and ops as far as rolling out changes to production. So, so we're going to work on a couple of databases here. So we'll start off in our dev environment, make some changes to our development environment, get those changes merged into our master branch. So we're going to be using Git workflow, which is we'll work on a feature branch. Once the feature is complete or our changes are ready to go, then we'll do a pull request to go into master, and then we'll do builds and releases from there. So the database that I'm working with today is this AdventureWorks database here. So I have 3 databases here that represent the higher environments that we'll be deploying to. So I'll start off making changes in the dev environment, and then later on we'll deploy the changes to those environments that you see here. So the first thing I want to do is to use JIRA to actually create a new feature issue basically in JIRA, so we can actually keep track of our features and also know what changes are associated with that feature that we're working on. So I'm going to go ahead and create a new feature here in JIRA, and I'm going to call this the collect additional details from users. And I'm just going to keep it simple here, and I'm going to create my JIRA issue here that helps us keep track of our stories. So if you're an agile shop, then this makes it really easy for you to keep track of your stories and your work that you're doing. So and again, one thing that I really like about Atlassian is how nicely their tools are integrated. So here you can see under development, I can actually create a branch right from JIRA into Bitbucket for this specific feature that we're working on. So I'm going to go ahead and create my branch. So as you can see, it's creating a branch name automatically for us, and it's actually branching out from master. So totally happy with that. I'm going to go ahead and create that branch. And here you can see we created our branch. So we already have a copy of our database in source controller, as you can see here. So there's a subfolder for each class of object, and within each of these folders, we stored a .SQL file for each object, and within that .SQL file, we stored a create script of all the objects. So we follow the model base where we keep track of how the state of your database changes in source control, and then when it comes to doing builds and deployments, we rely on our compare engine to compare the model or the state from source control against the target environments to generate the actual deployment script or the update script that you would need to run in order to deploy your changes to your higher environments. So, so my feature branch has the latest version of the database from source control, from master. So I'm actually going to go ahead and check this out locally on my machine and start working on this feature. So to do that, you can either use the Git command line or a Git client tool such as SourceTree, which is another really nice tool from Atlassian, which is actually free, that you can use to interact with Git easier. So I'm going to go ahead and quickly refresh my SourceTree to show that latest feature branch that we just created. And I'm going to go ahead and, oops, I think let me just double check here. I think I created a branch for the wrong story here. So let me go back into JIRA real quick.
And extra branches and unneeded branches and branch filth is a common problem. So it's kind of actually good that you're demoing that.
Exactly. All right, so it was this one that we actually need to create a branch for. So I'm going to go ahead and create my branch for that one. Okay, so this is the right one that we need to work on. So I'm going to go ahead and grab that one now. And I'm going to delete the other one that we don't need. All right, so now I've got my I've got this feature branch here, so I'm going to check it out on my local, so I can start making changes to it. So now our repository is on our feature branch, so I can go ahead and start working on this database. Now, when working with Git, we highly recommend that you actually work with your own dedicated database, because the main principle of Git is that you work on your local sandbox, and then you either push your changes to the same branch in your remote repository where everyone can grab your changes from, or merge into a specific branch and share your changes with everyone else. So it flows really nicely if you also have your own dedicated database to that will basically tie to the repository that you've checked out. So to demonstrate that, I'm actually going to create a new database here on my local. So I'm going to call it Adventure Works 2012 Git Arneh. All right, so I've got an empty database here, and let me just quickly set trustworthy on so I can use T-SQL-T on this database. All right. So, so we've got our empty database that we were going to work with. So the goal is to basically populate this database with the latest version that we just checked out from source control into the feature branch. So I'm going to go ahead and link my database to my local repository that we just checked out, which is sitting in this location here. Here we go. And I'm going to go ahead and link to that repository. Okay. Once this is linked to the repository, you notice my database icon turns green, which is an indicator of the database being linked to source control through our SQL source control plugin again. So this plugin basically acts as a bridge between your database, your development database, and your existing source control repository. So this works with Git, TFS, Subversion, Mercurial, Perforce, or any other source control system that you might be using. So now that we're linked to our repository, I can actually go ahead and say get latest, which is actually going to bring the copy of the database that, as you can see, we're currently on this feature branch, which is the one that we checked out. And in here, it actually shows you what objects and even data. So as part of SQL source control, you also have the option to commit data from your lookup tables or your configuration tables into source control. So you can also deploy that data as well as bring that data over to your local development databases. So the first thing that I need to do here actually is there are some custom comparison options that we've set for this project. So I'm going to apply those to my local first, and then I'm going to bring all the objects over to my database. So again, my database is currently empty, so if I expand everything, you can see there's nothing there. So I'm going to go ahead and select all the 285 objects, including data from our lookup tables that we have in source control, over to my database. So I'm going to go ahead and apply changes. So this is using compare in the background. So by default, compare tries to apply all the changes in a single transaction. So as you can see here, it's giving me a warning that full text indexes cannot be deployed in transaction. So compare will try to do it outside the transaction. And in this case, that should work fine. So I'm going to go ahead and acknowledge that and let compare or SQL source control actually generate my database with the latest version from that feature branch that we checked out. So here you notice in real time, it will actually populate my database with all the objects. And in a couple of seconds, you can see I have a working database that I can actually start making changes to.
Hey, Arneh, I'm going to put up the find out what everybody's using for their source control system, if any.
Yeah, go for it.
So the screen should be available, and please vote. Not shocked, mostly Git, followed by Team Foundation Server.
All right. Perfect.
I doubt that that's a surprise to anyone. Hang on, let me, looks like most people have voted. I'll close this and share it. Okay.
Yeah, it's amazing how Git is becoming just more and more popular as people move towards, more agile processes, DevOps, and most of it is because of how easy it is to do branching and merging in Git in comparison to the other centralized source control systems. So, all right, so so we can continue, right, Grant?
Yes, go ahead.
All right, perfect. All right, so so now I've got my database ready, so I'm going to go ahead and start making my changes and work on that feature. So I'm going to start making a couple of changes here. So we'll make some object changes as well as data changes to our lookup table, so you can see how that works and how you can deploy both data changes and schema changes together as part of a single process. So so let me just quickly refresh my. All right, so let's go ahead and start modifying the objects that we need to modify in order to start collecting more information from our end users. So here I'm using SQL prompt, as you can see, to select the columns, the additional columns that are interested in. So I'm going to add the person type and the title. And I'm going to format my SQL using prompt again to make it easier to read. And this way you can actually get everyone to follow the same syntax or style using SQL prompt as well. So under SQL prompt options, there's a lot of things you can do in terms of the behavior of the auto-completion as well as the coding styles. So you can even create your own style and export that so everyone else can import it on their end and start using the same formatting style for their SQL. So I'm going to go ahead and apply my change. Now with SQL source control, as soon as you modify an object, it will show these blue spheres next to the objects that are modified just to visually remind you that you have some changes to commit to source control. So when looking into DevOps processes, best practice is to make sure that you're always committing small units of changes at a time and even deploying small units of changes at a time. So this kind of helps you as a reminder that you got some changes to commit to source control. So before I commit this change, I'm going to go ahead and make a couple other changes as well. So so we're tracking data in a couple of our lookup tables. So if I go to my other SQL source control tasks here and go to link or unlink static data, so here you can see we're source controlling data in two of our tables. So when you get started with SQL source control for the first time, by default, it will only source control the schema of your database. So if you want to source control data in any of your lookup tables, then you would have to go into this window here and select the tables. The reason why my tables were already selected on this one, because we already had the project in source control. So all I did was pulling the latest from source control, which included the options that were already set by the project. So as a developer, I don't need to go back and set my own options. So make sure, this way we can make sure that everyone in the team basically has the same options set up on their end with SQL Source Control. So I'm going to go ahead and make a data change to one of these tables as well. So let me close this. And I'm just going to go ahead and insert a new data in the contact type. So again, another feature of Prompt is the snippet manager, so you can create snippets for specific SQL statements that you write a lot. So this will help you save a few keystrokes. So you can see II stands for insert into, so I can hit this tab and select the table that I want to insert into. And as you can see, it automatically populates the columns that this table contains and what data type goes into each column. So I don't need to go back and forth between my table in Object Explorer to figure out what I can insert into this table. So I'm just going to go ahead and call this a new contact type. So I'm going to call this the Bitbucket demo audio. All right, so we just added data to that lookup table. And I'm also going to make a quick change to one of my tables here as well while we're at it. So I'm just going to add a new column to the table, call it summary. All right, so got our changes that we wanted to make, and now I'm going to go ahead and commit these changes to source control. So let's go ahead and right-click on our database, commit changes to source control, which is going to commit the changes into our local repository. So again, here you can see at the top right corner, it shows us what branch we're currently on. So that way we can make sure that we are actually committing to the correct branch. So, so here it shows us what changes we've made, and at the bottom it shows us what's different between our development database and what's already in our source control repository. So here, the first item we're looking at is the data from our contact type. So as you can see, we track data as insert script in source control, and then when it comes to deployments, we compare the data from this file against the table in the target to identify what data differences exist. And based on those differences, we figure out what DML we need to run, whether it's an insert, update, or even a delete. In this case, you can see in comparison to source control, all the records are identical except that new one that we just added for the Bitbucket demo audience contacts. So that's going to get added to source control. If you look at our table here, you can see that it has our new column that we added. And finally, the store procedure. So again, you can see how that's different going from our development on the left side to source control on the right side. So I'm happy with all the changes. I'm going to go ahead and write my check-in comment. Made the necessary changes to gather more details from our users. All right, so I'm going to commit that into my local repository first. And as you can see here, it gives me the option to also push to the remote. So I'm going to use this option here to push to Bitbucket. And once these changes are pushed, then I'm going to go ahead and do a pull request in Bitbucket to go out to our master branch. And from there, we'll run a build in Bamboo and look at deployments going to our hiring environment. So let's go back to Bitbucket here. And I'm going to do a create a new pull request on my repository. So as you can see, we're going from the new feature into master. And here at the bottom, you can see what commits are associated with this pull request. And if you want to provide any additional description, you can do that. In this case, no one needs to review the changes since it's a demo. I'm just going to go ahead and create it. Oops. All right, that's better. And I'm going to also merge into master. And I can delete my branch since we're done with that. All right, So now that we merged our changes into the master branch, that is actually going to trigger a build in Bamboo to validate our database changes. So our DLM automation, which is one of the components in the SQL tool belt, is what gets plugged into your Bamboo or your build system or your release management tool to help you define your build steps and your deployment steps for your databases, specific to your SQL Server databases, as part of your DevOps process. So if we go into our project here.
I was going to go ahead and launch the, to find out what continuous integration system people are using, if any.
All right, sounds good.
And votes are still coming in. Give us a second.
Sounds good, and still waiting for the build to get triggered here.
Okay. Looks like most people have voted. Let me share the results here so people can see it. It's mostly TFS or none, which is cool. It's if you're using none, then you're in the right place. We're going to help you out.
Perfect.
Cool. I'll hide that now.
All right. So now let's go back to Bamboo here, and okay. So as you can see, our build started here. So it includes the merge that we did, and it also includes the original commit that we made into our feature branch. So you can easily see what changes are associated with your with the specific build that we're running. So what we're doing in this case is that we're utilizing, so there's two ways you can actually configure your build steps. You can either utilize our plugins to Bamboo or Jenkins or TeamCity or TFS or whatever build system it is that you might be using, or you can use our PowerShell commandlets to define your steps. So in this case, I've actually used our PowerShell commandlets to define what my build step should do. And as you can see, our build was successful. So what we do as part of our build step is we try to build the copy of the database that you have in source control or that specific branch from scratch on a temporary database. So you can specify your own SQL Server instance where you want to do that build, and it will go ahead and try to create your database from scratch on that server, just to make sure that you don't have any broken dependencies or any SQL Server compilation or syntax errors. So in this case, as you can see, the schema validation of our database from the master branch was successful. So as a result of that, it actually went ahead and created a new NuGet package, which is basically is our artifact going into our releases. So we're going to use this NuGet package, which contains the same folder structure as what we had in source control. So it contains this folder structure that you can see here in that NuGet package. So what we're going to do as part of the deployment is comparing this scripts folder from our NuGet package against our target environment to see what's different and also generate the deployment script based on that difference. So I'm going to go ahead and create a new release of this successful build. So if we go into the build here, you can see we can create a release. And we're creating the release of our master branch, and the new release is going to be version 9, which is okay. And again, you can see what commits are associated with this release, so you can look into the details. All right, so created my release. I'm going to go ahead and start the deployment to my testing environment. You can automate a lot of this. So if you want to automatically deploy changes upon successful builds and tests, in your build process to any environment, then you can do that. Or you can just trigger your deployments with a click of a button, as you can see here, to start the deployment. So what we're doing as part of the deployment here is we're running a comparison between the scripts folder from the NuGet package against the target database, in this case our testing environment. And based on that, it will generate some artifacts to show exactly what's different going from our NuGet package to our database on this server, which in this case everything is on local. And based on that, it figures out what changes it needs to make. So here at the bottom, you can see what changes it's applying to our database, and that was successful. And this also generates a report of what was deployed. So you can save those reports as artifacts, either on a network share or somewhere that can be accessed by everyone. So if I go to my Bamboo releases here and look at release 9, which is the one that we just did, and we've only deployed that to the testing environment so far. And if you look at this report, this will show you what changes, what differences exist between your source, which is this NuGet package, and the target, which is this database. So if I expand any of these objects, it just uses the Git style to, or Git syntax to show us what's different going from the source to the target. So in this case, we're adding a new column to that table. And we're also modifying the store procedure and modifying the contact type table where we added the data to that table. So you can also see if there is any warnings. So in this case, it's just telling me that the previous deployment had migration scripts, but this one doesn't, so which is fine. But if there's also any changes that could result into data loss, such as dropping columns or tables, or dropping indexes, so any risky changes, you would see a warning under this tab. And finally, the actual deployment script that is going to run in order to make our changes. So again, as you can see, this is using our compare engine and puts everything under a single transaction by default. So it starts off with our table and adds the column to the table, and then modifies the store procedure, and finally inserts the data into the table based on the comparison that it did. It saw that the only difference was this new record that we had, and based on that, it generated the insert script. So, so this is the deployment script that ran to apply our changes to our testing environment. So assuming that everything went well and the tests were successful, I can now go ahead and promote these changes to our staging environment, which is basically going to go through the same process again, which is basically comparing against the NuGet package and the target environment, and deploy the update script. So this process is obviously very customizable. So you know, we have some customers who just take, as part of their build, they actually run a comparison direct against production. They take that script and they try to execute that script against their lower environments, such as UAT, testing, staging. And what we do as part of our process of executing that script is that we capture the states of the target environment where we generated the script. So if you try to deploy that same script without running a new comparison, what we do is we compare the target state against this target folder to make sure that the target database that you're trying to execute the script on matches the state that we captured from the target when we generated the script. So if your target doesn't match this state, then it will fail your deployment, letting you know that there is a drift on that environment. So something doesn't match from when we created the actual update script. So you can do that, or you can just go ahead and do a single comparison per environment, and based on that, generate a unique update script for each environment. So as you saw, you know, it's pretty easy to see how everything is nicely integrated, and how we can help by integrating the database change process into whatever DevOps processes you might already have on the application side. So we still have another 4 minutes, so I'd like to stop the demo at this point and see if there's any questions that we haven't addressed yet, Grant, that we need to go
and I've got one last poll that I put up on whether or not they're using release management tools. And
Okay,
I
perfect.
think I've answered all the questions that are out there.
Okay, fantastic.
So if
Yeah,
anyone else has
so
any
a couple of
additional
things.
questions, please bring them up. But if you've got comments on any of the questions, go for it.
Yeah, just one on, so one of them is, how do you roll back DB changes without losing data that was added? I think you addressed this earlier on as you were going through the slides, but rolling back database changes in general is not an easy thing, just because of data, right? Application code is easy, but with databases, you generally always roll forward. So one thing you can do is utilize our compare engine to compare the current state of your environment to a known state, either through your NuGet packages that you had from previous builds, or just comparing against a copy of source control. Compare will give you a script that would basically bring the schema from whatever your current state is to the previous state. And that script that it generates will give you an idea of how risky it is to roll back at that point. So if it is dropping any tables or columns, then you know that this is going to result into data loss if data has already gone into those tables or columns. So at that point, you can either cherry pick stuff that you want to roll back and leave the other stuff untouched, and then do a roll forward. So commit that into source control again and create a new commit as a result of it, as opposed to doing a rollback. So that's generally what works best with databases.
So I showed off the who's using release management, and it's primarily just barely Bamboo. Octopus Deploy and Microsoft Release are all effectively tied, but none is the big winner, 45%. So I'll go ahead and hide that. And let's switch back to me. Oops, I didn't check which screen I was showing. Ah, good. Cool. So thanks, Arneh. That was a good demo. I really enjoyed that one. If you guys have any additional questions, what about getting data back during a rollback, like you mentioned? Well, now see, that's where things get fun. Generally, during a rollback, you're not going to be able to get data back because if data has changed, if data has been added, if data has been removed, a simple rollback, a clean rollback, is likely to eliminate the changes that are there. So generally, instead of a rollback, what Arneh is saying is doing a roll forward, which means, deploy a fix or deploy an undo that builds into itself something that protects your data. There's just no other methodology that I've ever seen that works for that.
Yeah, just restore a backup if it's a huge mess.
Yeah, well, I mean, but if you could just restore a backup, then you do that at the first moment. But generally, you can't.
Yeah.
Okay, so if you guys need help after today, we want to try to help out. Get in touch with us at databasedevops@redgate.com. You can definitely follow up on our solutions. We've got training course, and we have consultant partners that are out there doing this now, and they would love to help you out as much as we do. I love the cogged wheel there. It's my favorite graphic of what a DevOps process looks like. So you guys get to see my favorite graphic. And I don't see any other questions, so I believe that we are done.
Awesome. Well, thank you so much, Grant, and thanks everyone for your time, and I hope you have a good rest of the day.
I agree. Thank you, Arneh. Appreciate it. That was a great job, and thanks everybody for attending.
Thank you. Take care.